This is part 1 of Module 2 in the Foundations of Programming with Python video series. In this module we will be covering what data is and how it is being used and processed in programs. Also in this module we will be using IDLE as our IDE, not just the terminal and text editor, but actually using IDLE as IDE. So first of all, what is data? Data exists in two states. It's either stored on a drive, which is called persistent storage, or it is loaded into memory, which is non-persistent. What does this with the persistent and non-persistent mean? So persistent storage means if you turn off your computer, the data stays. It is still accessible after you turn on your computer again. Non-persistent data, so if it is in memory, is being lost the moment you turn off the electricity on your computer. This is what persistent or non-persistent means. And so to store data on a drive, there is a variety of ways how this is possible. So some examples include a simple text file or binary files, then the computer's registry, or you can use databases. At the end, all the information is saved in files on drives. It's just organized in different ways. In order to actually be able to, for the data to be useful for a program, it needs to be loaded in memory. So you only can work with data once it is in memory. All the modifications to data, and that includes adding or deleting of the data, is happening in memory. This is true, that's universally true. And once the data has been changed in memory, and the intention is to actually keep the changes, it must be saved back to the drive. And if the program terminates or ends, all data in memory is associated to this program is lost. So the data, the non-persistent data, is no longer available once the program is terminated or is crashing or whatever. And an important note is not all program data must be saved. So for example, if you're using temporary values to run your program, or if the intention of the program is such that it is not necessary to store the data, then we're talking about temporary values and you don't need to save them. So one example could be the calculator program. So if I'm just pulling up the calculator app here, is the purpose of this app is to function as a calculator. I don't need to save. If I'm now typing something in here, so there is my first bit of data that I'm going to be working with, and the second bit is actually I'm going to be doing an addition here, and that is my second bit or third bit of data, actually the 24. So you can consider this as your variables. First variable is 12, second variable is 24, your operator is an addition, and your result is 36. There is your third bit of data. I don't need to save this data. It's temporary because of the purpose of the program. It's a simple calculator. So now if I close the program, if I terminate the program, this data is lost. It's non-persistent, it's lost. So if I'm opening it again, then there is no data, there is no history yet, because it is not saved. So this data is lost that we did in the last instance of starting this program. This is what is meant. Not all program data must be saved. If the purpose of the program is to work with temporary data, you don't need to save it. Whenever you're loading data into memory from however the information is organized on the drive, you need to tell the computer or your program what kind of data is supplied. So the way the data needs to be ingested by the program is different if you're loading it from database, or if you're loading it from a text file, or if you're loading it from a binary file. You need to tell your program in what format you are expecting the data to come in. This is multiple purposes. For one, it allows the computer or the program to reserve enough memory and space to allow the data to actually be loaded. And it tells your program what types of data to expect and how to handle the data that is coming in. Typically, if you're saving data, you're not just saving one piece of information, you're saving multiple pieces of information. So these pieces of information, they need to be divided into how many pieces you have. So you need to tell your program what that looks like. Another example is if you're telling your program that you're expecting an integer, which is a form of a number, then you're basically telling the computer to set aside probably 4 bytes of memory. So if you tell the computer expect 1000 integers, the computer knows it needs to put aside 1000 times 4 bytes of memory space to be able to actually ingest that information that you're going to be supplying. All that reservation of the memory and the memory management is all done by you by the programming language. You don't need to take care of that. But in order for the programming language to be able to do it for you, you need to tell it what is coming. And also, if you are expecting integers, so this means and indicates to the computer to allow certain types of operations for an integer. It is not expecting text, so it would not be able of actually storing an A in an integer, because that is the wrong type. So it is telling the computer what to expect and how to handle it, and how to be able to process the type of data. And it also means that a computer typically reports an error if you are supplying data that does not fit to the type of data what you told the computer is going to be coming. Input and output. All programming languages have some form of inputting and outputting data. This can be in multiple forms. We already have seen a very simple way of inputting outputting data in Python with the print and the input functions. Print is the output because it's printing it out onto the screen. Inputting is ingesting data into the program. That is what we used in module 1, and this is what you already know. Yeah. So programs store the data in a variety of ways. What the heck? I need to delete this text. So here's our input output. Now, in order to tell a computer what type of data to expect, this is called declaring constants and variables. So constants and variables both are tools of holding data in memory. Constants are typically defined once when they're being declared and cannot be changed. Variables can be changed, but typically only with the same type of data. So if I'm declaring a variable as an integer and I'm assigning a value sometime in the program, I'm assigning the value 12 to it, like what we did in the calculator, then I can change this first variable at a later stage to 26. What I can't do is to change this integer, this number variable, to a string like saving a name. Looking at the string up here, saving name as. I can't change this integer type variable to a string type. So in most languages, you need to tell a computer what type of data you're going to be storing, and which is the declaring part, which assigns a data type to a variable. And in Python, the data typing is actually done automatically or implicitly. So Python in that regard is a very high level programming language and automates a lot for you in that regard. But this also means that you actually can change the variable type in Python during runtime. You should not do it, and it is due diligence of the programmer to avoid that, but technically it can be done. And here is a few variable declarations in different languages. So int x and a semicolon is actually declaring it in C#. You are first putting the variable type, then the variable name, and you are finishing the command with the semicolon. That's how it is looking in C#. In the SQL language, it would be x is an int, and you're executing this command with the semicolon in the SQL language. Also, you actually can see that there are different ways of invoking that there is a comment coming according to the languages, and in Python you are simply using x, and simply by using it, it's implicitly declaring the variable in Python. Sometimes you are going to be using constants in your programs, and it is actually good practice for certain things to set them as constants. So an example that comes to mind, if you are using file access multiple times, talking about again keeping the data persistence. So for example, you're using a program that when you're starting it up reads in some data, and you want to be able to actually save the data out back out to the same file. You can declare this file name as a constant. So throughout the program you are always referring to the file by this constant name, and what this allows you to do is you need to change the file name only in one location. So even if you have file access in, let's say in extreme case, 200 locations throughout your program, you are only changing the file name once, and all 200 times you're accessing the file is accessing the new file name. So this is a typical example, or one example that you can use, or where it is making sense to use constants. In most programming languages, there is, by declaring it as a constant, there is actually the restriction on it that you're setting the value when you're declaring the constant, and there is a limitation by the programming language on constants that you cannot change them. So there is no way in the programming language. It is a limitation. It's a safeguard that you can't change it. Not so in Python. Python allows you to change constants after declaring it. So this is something that is necessary to keep in mind, and it is due diligence of the programmer not to change it. Typically, or it's very common in programming, it's a very common convention that constants are named with all uppercase letters. So here you have a constant declaration. So it's a constant, it's going to be of a data type integer, it's all uppercase, and then you set the value. This is how you do it in C#. In Python, you simply use the uppercase, you set it. Technically, you can change it. It is the programmer's due diligence not to do it. And so variables can be changed. They can be initialized with a variable when they are being declared. So in Python, the first time you're actually using a variable, in this case x, you are setting it to a value of 5. So x starts with a value of 5. Later on in the runtime, you're setting x to 10. So now the value of x has been updated to 10. The 5 is lost. X now refers to 10. One thing to remember, and that is especially for the little bit older folks, and that is watching these videos, is that the assignment works that the value to the right of the assignment operator is being assigned to the variable on the left. So older folks have been taught in school that this is how functions are being written. 4 plus 5 equals 9. But actually, for programming, the correct notation would be 9 equals 4 plus 5. So you're calculating the 4 plus 5 and it's being assigned to the 9. That is how it would be in programming. So now it's in school, it's actually being typically this notation is being used, while older folks have been taught this way. So always remember this portion here. It can be a struggle to actually get this right for the little bit older folks. So that is a typical struggle. Putting this to test. So I'm going to be pulling up idle here. By the way, pulling up idle because we are using idle as our default IDE for this module. So what you actually can do here is you have your file. So you either can open files or you can create new files. Let me open a file. So you're simply going on open, and then you can go down into your computer as usual, as you would expect. So going down into module 1, opening Python file that we had here. Now you have it in here, and you also can run it in a Python shell. Run module, and then it's actually running. So this is how you use the idle. It's pretty straightforward. So now back to this code. So let's use idle here interactively. So we declare x as 5. Now if we're actually calling for x, we're getting 5 printed out, or we can do this to print it out. Is doing the same thing. Now if we declare y as 10, y is 10, x is still 5. Now if we would be declaring x equals y, the question is, what is x holding now? Is it 5, as we have declared up here, because x equals y, or is it actually holding 10? The correct answer is that it's holding 10, because what is happening? We are assigning to x the value on the right. Y equals 10, so y is 10, and we are assigning this value of 10 to our variable on the left. So what this is doing here, x equals y, is updating x with the value that is in y. It's assigning to x the value on the right. That's why we're getting 10. So this is what needs to be remembered about this assignment, or this assignment operator. Okay, this was actually already lab 2A, and so go ahead and do the lab, try it out for yourself, experiment a little bit with this for yourself to get familiar with that. This concludes part 1 of module 2.